Okay, let's go ahead and start. So last week we taught 3NF3A, which was equivalent fractions on a number line. It was awesome. On the quiz, scholars got 19% mastery, and then looking at the exit tickets, you had an average of 88% mastery, which is a huge growth, like 70%. So what do you feel like led to such an increase in mastery?
Being focused on teaching, so knowing misconceptions and then being prepared.
Yeah, great, love it. So today we're going to dive into question number 7. If you flip the page, this is what it looked like. If you remember this question from the quiz,
Yep.
Which had 19% mastery. And it represents 3NF3C, a different one of the bullet points on there. So why don't you go ahead and take 2 minutes then to decompose the standard on the front, and then we'll share it. Okay, great. Why don't you start with what you had for no?
Know what the denominator represents.
Okay.
Know what whole means, or like whole numbers.
And when you, let's just make sure we're clear then. So what does numerator and denominator mean? What would we want a kid to be able to say?
Oh, numerator represents the number of parts.
Special or
parts. Yep. Number of special parts. And then denominator represents how many parts. How many equal parts.
Equal parts.
And yeah. Okay.
And then what do you want them to know about a whole number? When we say whole number, what do we mean?
Whole numbers. Trying to think. I know what one whole is. Mm-hmm. Also, if I have more than one whole, it represents more than one whole amount. So if it's a whole number like 2, it represents 2 whole amounts.
Correct. So my whole numbers are like 0, 1, 2, 3, 4, yeah. Right? And then
fractions are not whole numbers. Well, no, they can be.
Yeah, I was going to say
fractions can be whole.
I was going to say I actually wrote that as a knowledge. Just whole numbers can be represented by fractions, or fractions can represent whole numbers. But I think a good way to think about it is that whole numbers are when we have no extra parts left over, right? And then let's also talk about what do we want scholars to know when the denominator is 1? What do we want them to know?
When I see 1 denominator, I know that it's just one part, and it's shaded. So it represents one part that is shaded.
Yeah, so yes, when my denominator is 1, like each piece is represented by one whole, right? Or each part is one whole. Okay. I don't split my whole into any parts. It's just one part equals one whole. Okay. And then if my denominator is 1, what do I know about that fraction?
That is a whole.
That it's either one, it's a whole, yeah. So we know that it's a whole when it's a
the denominator is 1, it is one whole.
A whole.
I mean,
yeah, because it could be 5 over 1 or yeah.
A whole amount.
Yep. Okay. The last thing that I had was just looking at this part of the standard, like locate 4 and 4 and 1 at the same point of a number line diagram. I just had that when the numerator and the denominator is the same, it represents one whole because we have all the parts in the whole. Cool. Let's jump over to show. What do you have for show?
So represent fractions.
And how would you want them to represent it? Using what? Yep. What else?
So numerator show what the numerator and denominator represent. So correct picture. Looking at the list we create. Well, you help me create. Show a correct picture if the numerator is 1.
Yeah. So I had the same thing where they just have to be able to draw an accurate picture in various situations. I also had just that they should be able to like generate fractions that are equal to a whole.
Okay.
And they should be able to just quickly say those because once they find the pattern, it's pretty good, pretty easy.
Okay.
Cool. Okay, so let's go ahead and dive into an exemplar for this question. So here's an exemplar for that question. Take 30 seconds to study it, and then we're going to share. We're going to just create a list of what makes this an exemplar, what's the criteria for success for an exemplar. So actually, if you just want to share out right now, and we'll make a list down here. So what's one thing you see that makes it an exemplar?
Correctly drew picture to represent fractions.
Yep. Did they draw just for one?
For
Yeah, so fractions, all of them, yep.
For all. Then they wrote yes or no. Or they picked yes or no.
Yep.
So they chose yes or no for each. And then that's it.
It's pretty straightforward. There's a lot of conceptual understanding that needs to happen. So let's talk about that. So how does this exemplar and how do these criteria demonstrate mastery of the standard?
Because they understood like 1/3, so they understood how to represent a fraction with a picture.
Yep.
They also understood that when the denominator is 1, they represent that correctly. So they need to understand that to know if it's equal to 1 whole.
Yep.
That's it.
Yeah, I think it's key, right? That we represented the fractions correctly, especially when the denominator was 1, and we knew that we needed to draw multiple wholes because each part is a whole. So now let's look at some of the students' other answers. So I pulled some student work, and I highlighted the number 7 on each. I want you to take a look and keeping these criteria for success in mind, what's the gap between this work and the criteria that we listed? So I'm going to give you about a minute to study, and then you can share out. So you just look at the highlighted part. Okay, what do you notice?
They didn't match them because they didn't draw or represent the fractions correctly with a picture or number line for each one.
Yeah, so we had a lot of them that look like this that just didn't draw it, right, or just drew the table. And then what do you notice about scholars like this? Yeah, what do you notice when they did draw it? What were they doing?
When they didn't draw it, they just still made 5 parts and then shaded the whole thing. So they understood that the 1 represents 1 whole, but just represent the numerator correctly. They did.
Yeah. So obviously we have like a procedural error where kids aren't actually drawing the picture, but then what do you think kids don't understand if they're drawing pictures like this?
Yeah. They don't understand that when the number is 1 in the denominator, what it represents, and then when whatever number is in the numerator, they don't understand how to represent that.
And let's be even more specific. When a 1 is in the denominator, what does it represent?
It represents 1 whole amount.
And we know that whole is broken into how many parts? Just 1, yeah. So it's not broken into any parts. So yeah, when I was looking through it, I had that scholars didn't understand that when the denominator is 1, then each part is a whole. Like each part is a whole. So let's take a moment now on the bottom of that first statement to fill out our gap statement, and then we'll compare. So let's take a minute to fill it out. Two scholars did not blank because they did not understand blank. Great. All right, what'd you have?
The problems that represent whole amounts because they did not understand when one is in the denominator, it represents one whole amount with one part, and the numerator represents the whole amounts or the special part.
Yeah, or the number of parts, right?
Number of
parts. The 1 is the denominator. My number of parts is just my number of holes because I have to draw a new hole for each. So I had scholars do not identify fractions equal to whole numbers because they do not understand that if the denominator is 1, then each part is one whole. But I actually like that you added on the numerator, so I'm gonna well, let's take 30 more seconds. Why don't you make any adjustments you want to yours, and I'm gonna add the part around the numerator is how many like holes I need or how many parts I need. Okay. So I said, yeah, scholars do not identify fractions equal to whole numbers because they do not understand that if the denominator is 1, then each part is one whole. I'm going to add and the numerator is the number of parts or holes. Okay, cool. So let's think about the reteach. So do you feel like this is a model or a guided discourse, and why? Why? Mm-hmm. Mm-hmm.
They have the mastery.
Yep. Yeah, the mastery is super low. We're not seeing any exemplars. So great. So this standard is a lot of conceptual understanding. The model is actually pretty straightforward when you actually understand what to do. So I want to spend some time thinking about the opening task specifically. So, so we're going to spend some time each scripting out the opening task and then just comparing notes so we can have a really strong opening task. So if you want to open up your computer, just open up to a doc wherever you want to take notes. So let's first, before we start scripting the opening task, let's just remind ourselves what's the key conceptual understanding that we want to stamp as a result of this opening task. So in kid-friendly language, what would that be?
When one is in the denominator, it represents a whole amount, right? Yeah, one whole amount.
Yeah, when the denominator is 1, each piece is one whole.
When the denominator is 1, each piece is one whole. One whole, so then I would have to explain.
Well, so this I want to just have this in mind so that when you do the opening test, you can do it. So why don't you type that so you have that in mind. So when the denominator is 1, each piece or each maybe part, I guess what we use more often, yeah, each part is one whole. Yeah, I mean, so as I would think about it for the denominator, it's a whole, and then remember the numerators is the ones that tell us that we need more, is a whole. So now what I'd like you to do is I'm going to put 3 minutes on the clock, and this might take some thinking or some jotting out, whatever you want to do. I want you to take about 3 minutes to think what could be an opening task that helps give kids, not the model, but like that like similar to the opening test that you do in your lessons, that helps them understand, oh, now I understand what the 1 when it's in the denominator is, okay? So just take 3 minutes to think about it, and then I'll compare it with something that I came up with. And as soon as you have your idea, you can type it, and then we'll compare. But yeah, feel free to scratch out whatever you want to. Yeah, you're good. No, once you start typing, once you have the idea of what you want to show scholars, like once you start typing your ideas. Okay, great. All right. Even though I know you're still working, why don't you? That's all right. Why don't you? Yeah. Why don't you? Yeah. Why don't you share what you're thinking, and then I'll share what I came up with.
So first, I switched the letters.
Okay. Sure.
So I'm gonna do some first.
Okay.
So Scott, I'm going to ask you. I mean, watch me as I answer this question. Write a fraction to represent each picture. So letter A. Looking at this picture, oh, I see that it's it's a rectangle split into two equal parts, and one is shaded. Well, now, denominator represents how many equal parts. Numerator, oh, it's one special part. It's shaded, so this picture represents 1/2. Letter B, it's two circles that are completely shaded. Let me look at this one. I need to write a fraction because I know it's two circles. I need to write. So I know it's just two. I need to write a fraction. So looking at this picture, let me see. Looking at this picture, first circle. Oh, it's just one part. And it's shaded. So that's one part. Let me look at this exact same circle. Oh, it's just one. Okay. So each is one part, but it's the whole thing. So my numerator, or I can just have them turn it. I don't know. But my numerator is 1. Now looking at my denominator, I know that's how many special parts. Both of these parts are shaded, but they're whole amounts. So it's 2/1 whole. But just looking at this picture, I know equivalent fraction is just two circles.
Let's pause there. I came up with this earlier. Read the opening test, and then I want you to read it and then share how is it the same or how is it different?
Okay.
What might you add to yours? you want me to act it out really quick? That might be easier because I know sometimes with the script. So here's what I was thinking. So saying, great, I have my rectangle here, and let's say I wanted to make a fraction. And let's say I wanted to represent this fraction. What would I have to do to this whole, Miss Meeks?
Break it into 4 parts.
Why would I have to break it into 4 parts?
Because that is the denominator.
Great. So I know that in my denominator tells me what, Miss Meeks?
How many equal parts?
Good. So I know if the denominator is 4, I'd have to break my whole into 4 equal parts. What if I changed it now? Let's say I changed it and my denominator was now 3. What would I have to do to this whole, Miss Meeks?
I
have to break it into 3 parts. Why do I have to break it into 3 parts, Miss Meeks?
The denominator changed to 3.
And that tells me what?
It tells me that it's 1 whole is broken into 3 equal parts.
Yep, so I know that I have to have 3 equal parts. Let me change it again. Let's imagine that the denominator is 2. What would I have to do to the shape?
Break it into 2.
Yeah, why do I have to break it into 2 equal parts?
Because it shows me that the denominator is 2 parts.
Good.
And 1 whole.
Now let me change it one more time. What if I change the denominator to 1? What would I have to do to the shape? Yeah, turn and talk with your partner. All right, and come back. What would I have to do to this shape?
We don't have to do anything to it because it's just 1 part.
Yes, so my denominator tells me what, Miss Meeks? Remind me?
My denominator tells me how many equal parts of shape is broken into.
And if my denominator is 1, how many parts do I have in one whole? I have 1, so I don't need to break into any shapes. When my denominator is 1, my parts are just 1 whole. Now what if I change this fraction to, say, this? What would I have to do to change my picture? Turn and talk to your partner. Come back. What would I have to do to change my picture?
We have to draw another hole.
Why would we have to draw another hole?
Because we're not breaking up our picture, we're just adding 1 to it.
Yeah, we know that each part is 1 whole. The numerator tells us how many what? How many parts. So if each part is 1 whole, how many parts do I need?
2.
So I need to draw 2 parts. Here's 1 part, here's another. What if I changed it to 3? What would I have to do, Miss Meeks?
Draw another rectangle.
Draw another rectangle. What if I change it to 4? Whatever I would do. Great. So, and what did I have here? So scholars, we know that when the denominator is 1, that represents a fraction that is equal to a whole number. We had 2 over 1 was equal to 2. We had 3 over 1 was equal to 3. We had 4 over 1 was equal to 4. Can anyone else tell me, just off the top of your head, what is a fraction that represents a whole number? Another fraction that represents a whole number. Ms. Meeks?
6 over 1.
6 over 1. Someone tell me another one. 10 over 1, 12 over 1. Okay, and C. So what was the difference between our opening tests and what did you like from each?
So you didn't have to model it.
Yeah.
It's more focused. And then you show them how they're different. And then you show, so that's a difference.
Yeah, and I think yours is really, I think what I like is I really like those tasks. And when I was putting together some of the practice, it's actually like super similar where they have to draw a picture and then say whether it's a whole. But my fear would be if we don't nail down the conceptual understanding, they're not going to be exactly sure why to do that. So how do you feel about this opening test?
Yeah, I like it.
Okay, great. So now we're going to have you practice. Why don't you take, if you want, feel free if you want to like practice draw or whatever, why don't you just take a minute and a half to prep and then we'll go live with it. Yeah, feel free.
That's one thing we don't have a lot of is like erasers.
And this can be projected or you can write on the whiteboard. We won't do the model yet because that involves pretty short. Ready to go? Cool. Why don't you stand up? I'll play the role of a student. I'll pause you when I have any feedback. Reference the script as you need.
Okay. Scholars, check the board. All right, check the board. Let's imagine I wanted to show this. Oh, I wanted to show this fraction using this whole amount. So the fraction here is 1/4. What do I need to do to my whole amount, Justin?
You need to break your whole into 4 equal parts.
Why do I need to break it into 4 equal parts?
You need to break it into 4 equal parts because 4 is your denominator, and that's the number of equal parts in the whole.
That is correct. Scholars, what if I change the fraction that I want to show? I'm still using the same whole amount, but now the fraction is 1/3. What do I need to do to this whole amount?
You would break the whole amount into 3 equal parts.
And why would I break it into 3 equal parts?
You break it into 3 equal parts because 3 is the denominator, and that's the number of equal parts in a whole.
Good, so we're just focused on the denominator. Now, looking at this fraction, what if I wanted to represent 1/2? What do I need to do to this whole?
You need to break it and put one line down the middle and break it into 2 equal parts because the denominator tells us that there's 2 equal parts in a whole.
So we still looking. What if I want to change and represent this fraction? 1/1. What do I need to do? Turn it to your partner. Turn it back to me. Just.
You don't have to do anything.
Why?
You have to leave it alone.
And why would we have to leave it alone?
You have to leave it alone because the denominator tells us how many parts, and there's only one part in a whole, so we don't need to break it into any more parts.
That is correct. Good. Yes. So scholars, when my denominator is 1, each part is 1 whole. It's just 1 whole.
Okay, why don't you highlight that just so when you reference it tomorrow, you can see it. But you can see that. You don't need to do anything because the denominator tells you the number of parts, and there's 1 part in the whole.
Yes, stop. When my denominator is 1, each part is 1 whole. So now, stop. You know how to represent 1 whole. You know how to represent the denominator when it is 1. Let's look at further at this picture. So now let me look at my numerator. I know that's the number of special parts. So let me change. What if I change my numerator into 2? What would I need to do to represent 2/1? Justin.
You need to draw another rectangle.
And why would I need to draw another rectangle?
You need to draw another rectangle because the numerator tells you how many parts you have, and right now you only have 1 part, so you need another part.
Good. What if I drew another rectangle? What would that change my fraction to?
Now your fraction should be 3/1 because you have 3 parts.
All of them are the same, so they represent the same. Looking at this, I see that 3/1 is the same as 3 whole rectangles. So scholars, when we have a fraction with 1 in the denominator, we know that that represents 1 part. 1 in the denominator represents 1 whole. And when the numbers in the numerator, those are our special parts, they still have to have 1 part. But they also...
Everything trying to say that when the denominator is 1, the numerator tells us how many wholes we have.
Okay.
So, when the denominator is 1, we always know it represents a whole number.
Okay. So, scholars, now looking at this fraction, and we have 3/1, when we have 1 in the denominator, it shows us that each part is 1 whole. And when the numbers change in the numerator, they represent the special parts, but we must keep them the same with 1 whole. So they're equal to whole amounts. This is 3 whole amounts. If I draw another rectangle, what fraction would that be?
4/1.
4/1. When I say go, we're looking at 4/1. Turn it to your partner. How many whole amounts is it? Oh, what whole number is equal?
Yeah, I think from here you can. I think what you can do is like help them see the pattern. So like we listed a lot of fractions that were equal to a whole. 1 over 1, 2 over 1, 3 over 1, 4 over 1. Those are all whole numbers. Can someone tell me really quick, who can tell me other fractions that are equal to whole numbers?
So we went over fractions that were all equal to whole amounts. So we had 1 over 1, 2 over 1, 3 over 1, and 4 over 1. Can someone quickly tell me other fractions that are equivalent to whole numbers?
7 over 1.
Yes, 7 over 1.
81 over 1.
Yes, 81 over 1. Yes. So scholars, we know that when 1 is in the denominator, no matter what number is in the numerator, it's equal to whole amounts.
That's great. So let's put a star just by that last question or highlight it so that you know that's the one part that we adjusted as well. Just asking Costello to tell you any other fractions equal to a whole. Okay, so looking at getting this scheduled, given that I think there isn't a number story scheduled for tomorrow, I think we should just do this for number stories tomorrow. That sound good? And then I'll be in there to see it in action, and then put the exit tickets in the exit ticket tracker just like normal, and have them to me by Thursday first thing, and then we'll see how mastery increases. Sound good? Yes, yeah, because you have the normal lesson, then you'll have that lesson as well. I went ahead as well and printed some materials for it. So this is when you do the model, and then the practice, and then an exit ticket. So all the materials are there as well.